Hello everyone, welcome back to this video on one of the most powerful techniques in algorithm design, that is dynamic programming, which is also known as DP. Okay. First, what is dynamic programming, that is DP? Dynamic programming is all about solving complex problems efficiently by breaking them down into simpler overlapping subproblems and solving each of those just only once, and also storing their results for the future use. Instead of recalculating results again and again, we can store and reuse the results. Okay, saving both time and effort. Time and effort. So on the whole, what is dynamic programming is all about solving complex problems efficiently by breaking them down into simpler overlapping subproblems, solving each of them just only once, and storing their results for the future use. We will not be recalculating again and again, and will store and reuse the results, saving both time and effort. Okay. Now let's walk through the general method of dynamic programming using 5 key steps. First one is characterize the structure. What we'll do in this step is we'll start by understanding how large a problem or the subproblem is, how large a problem is, and how can it be broken into smaller parts. How can it be broken into smaller parts? Okay, parts. Think about how solving subproblems lead to the full solution. Now thinking about solving subproblems leads to final solution. These 3 questions are handled in the characterize the structure. What is that? Defining the problem in terms of subproblem means how large a problem is and how it can be broken into smaller parts, and identifying the solution to the smaller subproblems leads to the final full solution. This is the first step. Second step, defining the state. Next, we'll decide what we want to store. This is usually a value like dp of 1, representing solution for a subproblem of size 1. Okay. Now, in define the step is we'll decide what data will be stored in your DP, that is dynamic programming table. DP of 1 could represent the solution for the first I element. So in this step, we'll decide what we want to store. This usually the value is stored in the DP table, DP of I, representing the solution for a subproblem of size I. Next is building the recurrence relation. Formulating or building the recurrence relation. We'll write a formula, a recurrence. In this step, what we'll do? We will write a formula, a recurrence, that shows how each state depends on the previous one. How each state depends on the previous state. Okay, previous one. This tells us how to fill our DP table. So what are we doing in the third step? We are writing a formula, or we are writing a recursion. We are writing or building a formula or a recursion that shows how each state depends on the previous state and how to store the results in the DP table. Write a recursion formula that relates the result of the problem to the results of its subproblem. Okay. Now, in the next step, fourth step, we will choose the approach. Choose the approach. Approach can be bottom up or top down approach. Top down is known as memorization with recursion, and bottom up is known as tabulation by filling a table iteratively. Next, store and reuse the results. Finally, we use an array or matrix or dictionaries. Array, matrix or dictionaries to store answers and reuse them as needed. Store answers and reuse as needed. Okay. This is what gives DP its power. So what is the power of DP? DP power is store and reuse, is the power of dynamic programming. Let's take a quick example of Fibonacci series. I hope you remember the two types of approaches. We'll be using one of the approach. Here, this top down and bottom we have discussed in the previous videos. If you want to clearly know about these approaches, you can watch our previous videos. We are not going deeper into these approaches because we have done a lot with these two approaches in our previous videos. Next, quickly going to the example, Fibonacci numbers. Here, f of n is equal to f of n minus 1 plus f of n minus 2 with the base case of f of 0. What is the base case here? Each iteration should have a base case. This also we have discussed. Okay. What is the base case in this Fibonacci f of n? Is f of 0 comma f of 1 is the base case, so that it will terminate it and it will not go to infinite loop. What is the base case? It will terminate it and it will not go into the infinite loop is the base case. So by storing each computed Fibonacci number in a table, we avoid recomputation and greatly speed up the process. Now what we'll do, we'll store each computed Fibonacci number into DP table. Okay, we avoid recomputation and speed up the process. No recomputation and speed up process is what we're going to do. So instead of using recursion, which is inefficient for large n number of repeated calls, we build the solution from the bottom up approach. So instead of going from top down approach from n to 0, we'll be going from bottom up approach. We have chosen bottom up approach here. We'll create a list DP of size n plus 1. First we'll create a DP list of size n plus 1 to store computed Fibonacci values. We'll first initialize the base cases f of 0, f of 1. DP of 0 is equal to 0 and DP of 1 is equal to 1. Now we'll iteratively compute each Fibonacci number from 2 to n plus 1. Okay, now as we are going from 0 to n in the bottom up approach, We'll first initialize dp of 0 and dp of 1, which is 0 and 1, and from the range of 2 to n, as we are taking from 0 to n, 0, 1 we have known values, and from 2 to n we are calculating each Fibonacci number, and then we'll store it in dp of n. Okay. So resulting, as we are storing in dp of n table, we can reuse the values and calculate the Fibonacci till nth value. Any of the value, irrespective of values, we can draw the Fibonacci results from dp of n, as we are storing from 0 to n in this table. Okay. So why is this efficient? Why is this dynamic programming efficient? Dynamic programming is perfect when your problem is optimal structure and overlapping subproblems, because it has optimal substructure and overlapping subproblems. The dynamic programming is a perfect solution. Okay. What is optimal substructure is, problem can be broken down into simpler, smaller subproblems, and overlapping subproblem occurs when subproblems are solved, same subproblems are solved multiple times. In both these cases, that is optimal substructure, where problem can be broken into, major problem can be broken into smaller subproblems, and overlapping subproblems, where subproblems are solved multiple times and the results are calculated and stored. Where these two characteristics exist, dynamic programming is a perfect solution. Thank you.